Okay, so what we're combining here is we have 20% that we're asked to combine with 28% in the hopes of creating 26%. Do we know the volume or the amount for either of those?
300.
300, which goes with which one? 28. So we'll put X here, because that's what we're trying to find. How much of the 26% do we have? X plus 300. This plus that equals that. So now we have 20% times X, that's 0.2 times X, plus 28% times 300, so that's 0.28 times 300. Is going to have to equal 0.26 times its amount of X plus 300. So now we're going to simplify the equation and solve. So 0.2x is just 0.2x. 0.28 times 300 is 84. Over here, we're going to multiply the parentheses by the 0.26. So 0.26 times x is 0.26x. And then 0.26 times 300 is 78. So now what? Well, we have an x on each side, so we got to get rid of one. Get rid of the smaller one, which is the 0.2x. This is 84 equals 0.2x minus 0.2 is 0.06x plus 78. And then subtract 78, we get 6 equals 0.06x. And finally, divide by 0.06, 100 equals x. So the 100 milliliters are the 20% that we would add to the 300 milliliters of 28%. Now for the automotive industry, what might be more applicable is this. Let's say you have a 12-liter cooling system. In other words, your radiator. Say it tests at, what am I putting here? Let's say it tests at 36%. Is that going to work? Yeah. So it needs to be 52%. How much should you remove and replace with pure antifreeze? Yeah, but you want to go on the cheap. You want to just drain out as little bit as you can and replace and see what's.
Yeah, but if you can afford a pure antifreeze, right there's already 8 quarts, or 8 liters, or whatever the hell it is, 8 quarts. So you might as well just buy one more and.
Okay, so.
Well,
what are we combining? What 2% are we combining here? We have the 36%. What are we combining with it? 100%. Very good. And we're hoping to get 52%. Do we know the amounts of any of these? Well, we know that when we're all done, we're going to have 12 liters, right? So the 52% is 12 liters. We're trying to find the amount of the 100% or the pure antifreeze. That's X. How much would the 36% would there be then? We started out with 12 liters, but we took out X liters. We removed X liters and added the pure end. So in this equation then is going to be 36% is 0.36 times 12 minus X. Plus 100% is what is a decimal? 1 times X equals 52% is 0.52 times 12. So back up here, we're going to multiply the parentheses. 0.36 times 12 is 4.32, I believe. 0.36 times negative X is a negative 0.36X. Next, 0.52 times 12 is 6.24, I believe. I better double check that. Yep. So now what? When you combine our negative 0.36x and positive 1x makes a positive 0.64x. This is 4.32 here yet. Equals 6.24. And then subtract 4.32. 0.64x equals 1.8. 1.9, isn't it? 1.92. And then divide by 0.64. X equals 3. So you'd have to drain out 3 liters and replace it with pure antifreeze. Simple enough?
I would have simpler.
You would have simpler, drain the whole thing and start over. This might work with like a foot bath or something like that. Let's say you have a foot bath, you have a 5, let's do a 4 gallon, let's do a 20 quart, that'll be 5. 20 quart bucket. And it is tested at 64%. How much do you need to dump out and replace with pure water? To get to, excuse me, 48%. I'm gonna let you guys try that in your notes, see what comes up. Just gonna push you on the way. What percents are we adding here? We started out with how much? With what? 64%. We're combining that with water, which is 0%, and hoping to get 48. So let you guys take it from there. So we have the 20 quarts. What does that match up with? What's going to be, which percent is going to be 20 quarts? The final amount will be 20 quarts. We've got a 20 quart bucket.
Would be 2.
Well, it started out as 64, but we're going to drain some of that out. So the amount of water we added is X. The amount of 64% that we ended up with is 20 minus X. Because we took some of that out and replaced it with water. You're thinking if we just added water to it, then that would be the 20 quarts, and then the 48 would be 20 plus X. Or X plus 20. So this is 0.64 times 20 minus X. Plus 0 times X is 0 times X. Equals 0.48 times 20. 0.64 times 20 is 12.8. 0.64 times negative x is a negative 0.64x. 0x I don't have to worry about. Equals 0.48 times 20 is 9.6. So I'm just solving the equation. I will subtract 12.8. I have a negative 0.64x equals a negative 3.2. And I divide out negative 0.64. I get x equals 5. So I drain out 5 quarts to replace it with water to dilute it down. If I ask you to solve F equals MA for A, what it's asking you to do is the same thing it's asking you to do here. If I ask you to solve this for X, what would I do? I would divide by 4, correct? Got 2 equals X. Same over here. If I'm solving for A, what's keeping A from being by itself? M. M is multiplying it, so to get rid of it, I'm going to divide by M. I have to divide the other side by M. What is F divided by M? F over M. So A equals F over M. If I have, now if I'm only going to do this once, where I'm going to take a measurement and find F and find M, I would just find F and M and plug them into this formula and solve for A. But if I'm going to do it over and over again for different values of F and different values of M, it's easier to have it solved like this. Now I can just plug in numbers there and divide, and I can calculate A. Or I might have a slightly more complex formula like power equals I squared R, and we're actually going to solve for I. So I have to get I by itself. I'm going to divide by R. P divided by R is P over R. Here I'm left with I squared. What do I still have to get rid of there? Okay, get rid of the squares. I got a square root. So that's gone. I have to make sure the square root covers both the P and the R. So square root of P over R equals I.
Would you split, like say P is 4 and R is 16, would you square root them before you divide, or would you do it after?
Either way would work, actually. Technically, you should divide them first if you can, then square root them. But square roots are distributive. So you can divide each piece separately, or square root each piece separately if you want. Let's say I want to solve P equals V squared over R for R. How do I solve that for R? R is on the bottom of a fraction. Well, I can do this. If I make this one into a fraction, now I have a proportion. And if you remember when we had something like 3/4 equals, oh, let's see, 15 over blank. How did I find this missing number? Cross multiply. 4 times 15 is 60. And divide by 3, right? Gave me 20 there. I do the same thing here. I'm trying to solve for R. I'm going to cross multiply. 1 times V squared is V squared divided by P. So R is equal to V squared divided by P. So I can solve in these generic formulas for a specific variable. I could also be asked to evaluate. Once I've got that formula rearranged, the reason I'm rearranging is because I'm going to have to evaluate it probably multiple times. So I might ask you to evaluate A equals L over 2 times W times D plus little, big D plus little d, where L equals 12 W equals 7, big D equals 11, and little d equals 5. Evaluate means give value to. Replace those variables with those numbers. So L is going to become what? 12. So instead of L over 2, it's 12 over 2. Times W will be 7. Times, yeah, big D's 11, little d's 5. So 11 plus 5. Now it's order of operations. Order of operations says we have to do enclosing symbols first. So that is right here. 11 plus 5 is 16. Now what's in the parentheses is down to a single number, so I don't need the parentheses anymore. I make sure I put in that multiplication there because there was a number in front of the parentheses. Now what's next? Yeah, it's all multiplication and division, so I'm just going to go left to right. 12 divided by 2 is 6. 6 times 7 is 42. And 42 times 16 is 672. So A is 672. Good stuff. I'll have you do one more. How much 28% solution would you mix with 750 milliliters of 40% solution to create 36% solution? Try that one in your notes quick, and then I'll give you guys your homework for the day. So here we are mixing 28% and 40%. Anybody get an answer?
Yeah.
What'd you get?
375.
Cool.
I don't know if it's right.
We'll see. So we're mixing 28% and 40%, hoping to get 36%. We have 750 milliliters of the 40%. So this time we're not draining anything. That's the amount we have. We want to know how much 28%. So that's going to be X. So how much of the 36% are we going to get? X plus 750. So now we're going to set this up. This is 0.28 times X plus 40% is 0.4 times 750 equals 0.36 times X plus 750. 0.28 times X is 0.28X. 0.4 times 750 is 300. That equals 0.36 times X is 0.36X. 0.36 times 750 is what, 270? Is that correct? Now I have to get rid of one of the X's. Which one am I going to get rid of? Smaller one, the 0.28. So 300 equals 0.08x plus 270. And then subtract 270. $30 equals 0.08x. And then divide by 0.08. So this come up to be 375. It's 375 milliliters. Any questions? Okay. So homework. Page 267, exercise 6.7, 1 through 19, the odds. Page 270, exercise 6.8, 1 through 25, the odds. Those are on rearranging the formulas and evaluating expressions. And then you probably should go back and take a look at page 264 again. I assigned this last time, but you should go back to it and make sure you got it understood. Page 264, exercise 6.6, 1 through 25, the odds. This does officially bring an end to Unit 3, which means tomorrow will be your Unit 3 test. Which then leaves us with 2 full weeks to cover Unit 4.